Okay.
In mathematics and civil engineering, traffic flow is the study of interaction between vehicles, cycle, drivers, and infrastructure, with the aim of understanding and developing an optimal road network with efficient movement, traffic, and minimal traffic congestion problems. Traffic flow is the theory developed based on flow of vehicles on the lane and its connection with other vehicles, pedestrian, signal, present on the road. Free movement of traffic is affected by many factors like design speed, percentage of heavy vehicles, number of lanes, and intersection present along the road. Traffic flow is a road is in a road is expressed as the number of vehicles using the particular road per unit duration of 1 hour. It is measured using traffic counts made for a particular duration at one point on the lane stretch. There will be a variability in the count made during the different hours of the time on a particular day. For any analysis to be made based on traffic flow, peak hour is traffic. Peak hour traffic is considered. Traffic flow is a measurement is required on the road to locate the point on the road where congestion happens, assessing the requirements or traffic signals at an intersection, estimating the capacity of the roadway to meet with the present flow. Traffic flow is dependent upon two parameters, speed of traffic and, and density of vehicles on the road. For the flow to be without congestion, density of vehicles should be not be more than 30 vehicles per mile length. Free flow speed on a freeway should be 75 for improved level of service on a mile particular road. On an on, a, on an urban road, free flow speed should be maintained around 50 miles per hour. Traffic flow is measured using sensors, loop detectors, video measurement, and manual count of vehicles subject to the magnitude of traffic counts. Measured traffic is converted as annual average daily traffic or AADT. Designed hourly volume for the purpose of pavement design, provision of lanes, and etc.
For the objectives, the aim of the project is to analyze the traffic flow of each street by applying a linear equation system in which they will identify the vehicle speed and the number of vehicles on each road.
So for the problem, here's a diagram that shows a small network of streets, assuming all streets are one-way streets and direction of traffic are indicated of the arrows. For reference, it is useful to name intersection in the network, so we'll name them A, B, C, and D. So we need to find the flow rate of cars on each segment of streets.
The solution for this problem is first we have to determine the given values of in this problem. So first we indicate the x of 1, x of 2, x of 3, x of 4, and x of 5 in the given diagram. And then we first get the value of the incoming vehicles to the intersection A, B, C, and D to the outcoming vehicles. And thus we have an equation of 170 cars per hour plus x4 is equal to 240 cars per hour plus x5. Next, and then second is we determine the value of the interior intersection from intersection A, which connects the three streets. That is 170 cars per hour is equal to x of 1 plus x of 2. Another is the intersection B, which has four streets, x of 1, x of 3, and then the 90 cars per hour, and then 240 cars per hour. That gives us an equation of x of 1 plus x of 3 plus 90 is equal to 240. The other is the intersection C that have also a um, four streets that is a this is x of 2 plus x of 4 is equal to 140 cars per hour plus x sub 3. And lastly, the intersection D have a three streets that connects it from 140 from that have a 140 cars per hour is equal to 90 cars per hour plus x sub 5. And simplifying this, we have an equation of x sub 1 minus x sub 5 is equal to 70, x sub 1 plus x sub 2 is equal to 170, x sub 1 plus x sub 3 is equal to 150, x sub 2 minus x sub 3 plus x sub 4 is equal to 140, and x sub 5 is equal to 50. The solution for this using the MATLAB, as you can see in the given picture, we, we make a matrix A of 5 by 5 matrix, and then a 5 by 1 matrix of matrix B. And with the variables of x of 1, x of 2, x of 3, x of 4, and x of 5. And then continuing, um, we combine these two matrices in matrix M. And thus we have a 5 by 6 matrix M. The next part, we get the RREF of this matrix M. And thus converting this matrix R to the equation we obtain, x sub 1 plus x sub 3 is equal to 150, x sub 2 minus x sub 3 is equal to 20, x sub 4 is equal to 120, and x sub 5 is equal to 50. If we let x sub 3 is equal to if we let x sub 3 equal to x, we have x sub 1 is equal to 150 minus x sub 2 is equal to 20 minus s, and x sub 3 is equal to s, x sub 4 is equal to 120, and x sub 5 is equal to 50.
In this problem, we are finding the flow rate of cars on each segment of the street from the calculation we perform in MATLAB. We conclude that if we would let x sub 3 be a whole number which is 3, then x sub 1 is equivalent to 150 minus s, x sub 2 is equivalent to 20 minus s, x sub 3 is equivalent to s, x sub 4 is equivalent to 120, x sub 5 is equivalent to 50. As the result of our computation, we didn't determine completely the traffic flow on all the streets, since we have still one variable which is x sub 3. It is still undetermined, which we started our computation with insufficient data. We need to measure one more street, which is C and B, and after the measurement, we will now have a value for the x sub 3, and then we will now determine the flow of the traffic in every street of the network.
That's all. Thank you.